already got a ton of stuff written down. Probably is. Okay, here we go. Solve triangle CHS. Okay, quiet. Here we go. This will be a quiz. Hopefully we can all get a really good grade on. So we got to solve this triangle. Tell me what we ought to be able to figure out right off the bat.
What H is?
We ought to be able to figure out what angle S is. Remember that the angles of a triangle add up to 180. So if you know two of them, it is easy to find the other one. So I got 65. Did you? So there you go. The problem is a third done, and all we did was subtract from 180. Okay? Now, we need to find either side H or side S. It doesn't matter. The order you do that doesn't matter. So which one would you like to find?
H.
H? So if we're finding H, what are we going to set up? What's our proportion going to be?
Sine 53,
Sine,
14.
exactly. Now let's stop right there. Nate is exactly right. No matter what you're shooting for, H or S, you need to start with the pair. Okay? And you'll have a pair, because this quiz is over the law of sines. So you're going to have a pair, and that's the pair you're going to start with. Now, if we're doing, what do you say, H?
Yes.
If we're doing H, then we'll say sine 62 over H. Now remember, it's sine angle. Don't just put 62 over H. It's sine 62 over H. Okay, so then what do?
Divide.
Well, we don't divide yet.
Cross multiply.
First we have to cross multiply, and then we will divide. So we'll have H sine 53 equals 14 sine 62, right? And then we'll divide by what? Oh wait, what are we solving for?
H.
Our variable is H, so what do we need to divide by? Sine 53. So H equals 14 sine 62 over sine 53. And I just typed that in exactly as it is. So 14 sine 62, close parentheses, divided by sine 53. And I got 15.48. Okay, well, you want to make sure your calculator's set in degrees.
You're right. Yeah.
And then, in this chapter, everything we do is in degrees, okay? So we have no need for radians in this chapter. So set it in degrees and leave it in degrees.
Oh, never mind.
Did everybody, or did somebody else get 15.48?
Yeah, I did.
Okay, perfect. Now we're moving on to side S, which we will do exactly the same way, starting with exactly the same thing. So we'll start with sine 53 over 14, but this time we'll set it equal to sine 65 over S. Right?
Yeah.
And then we will cross multiply, just like we did before. That's an S, it kind of looks like a 5. It's an S. So S sine 53 equals 14 sine 65. This is your variable. S is your variable, so you're going to divide by sine 53. And that's what you're going to type in, right? So 14 sine 65, close parentheses, divided by sine 53 is 15.89. So over this is exactly what your quiz looks like, okay? Exactly. So over here, in the blanks, you put down angle S is 65, side H was 15.48, and side S was 15.89. I think that's easy if you've been paying attention, right? Make sure you can type it in on your calculator. All right, so that's number one. Are we all good with that? All right, so then number two is that how many triangles are possible thing. Now, the reason that I put show work is because I'm not going to give you credit for a guess. These are pretty easy to guess because what are the only possible choices? How many triangles are possible? 0, 1, or 2, right? So you got a 33% chance of just guessing right. How many triangles are possible? 0, 1, or 2 every time. That's how many you're going to get. So here we go. We have triangle LKF. I'm an egomaniac. Those are my initials. And we are going to figure out how many triangles are possible with this one.
What's a 63?
Oh, thank you. I'm so busy getting excited about my initials. All right, now, we start this problem exactly the same way. Exactly. So what's our pair?
L's.
The L's. So we'll say sine 63 over 15. It's sine angle over sine. Sine angle. And then we'll say sine K over 14. We don't say sine F over F because we don't know either one of those. So we say sine K over 14. Is that okay? Now we cross multiply, just like we do. 15 sine K equals 14 sine 63. Now this time when we divide, pay attention, this is your variable. So what are you dividing by this time?
15.
The 15.
Second.
And in the problem we just did, when we got to this point, it said H equals. So we just typed it in. This one says sine K equals. When it says sine K equals, then you know that you can't just type it in. You have to do second sine and then type it in. So if it just said K equals, then you would type it in. But when it says sine K equals, you have to second sign it. On these how many possible triangles questions, you're always going to have to do second sine, 14 sine 63, close parentheses, divided by 15. Now, what happens sometimes when you do that? You get an error. If that happens, then I would double check it to make sure I typed it in right. But if I get error, then that means there are no solutions, right? No triangles. I got an answer though. I got 56.26.
Oh, that means 2.
Okay? So then I come over to the side and I put my 63, my 14, and my 15. And then I take 180 minus that answer and put it here. And then I stand back and look at this triangle and say, does that make sense?
No.
No, why not, Jaden?
It's already more than 180.
This is more than 180 already, and I haven't even figured on that one yet, right? So does that triangle make sense? No. So how many triangles are possible? Just one. The one that was with the 56. Just one. So all this work is shown, but the answer to the question is 1. Okay? If this had come out to be 103, then would that triangle have made sense? Yes, and then the answer would be 2. But it didn't.
Wait, how'd you get that again?
Yeah.
Corner?
180 minus the original.
Okay.
It's always done the same way. It's 180 minus the original. All right. So next time we gather, which Jaden has figured out is Friday, we'll have a quiz that looks just exactly like that. So 2 questions, law of sines.
You give quiz out like candy.
Huh?
I said you give quizzes out like candy.
Well, it seems like that because we have class so seldom, unfortunately. Okay. So now, besides, some of you need some points. And this should be an easy one. All right, so now, let's go back to our notes. And let's pick up where we left off yesterday, which was with the law of cosines. Now, before I jump into a problem, I want to go back over how the law of cosines works. Okay? So I'm just going to draw a random triangle up here. And I'm not even going to give you any numbers. I'm just going to use letters because I want you to see how the law works. Do you remember from our notes yesterday that the law of cosines is big? It's a big, long thing. When you do a law of cosines problem, you will only have one angle. There will only be one angle involved in the law, all right? So I'm just arbitrarily going to say angle B is the angle that I've got in this particular problem. If that's the case, then when I write my law of cosines, over here, all by itself, will be side B squared. Remember, the law of cosines has one angle. When you do it, you'll be using one angle only. If that angle is angle B, then over here, all by itself, the only thing on this side of the equation will be B squared. Okay? If you were using angle C, the only thing over here would be C squared. And then at the other end of the problem is cosine B. So if you're using angle B, you got B squared over here, and on the end, you have cosine B. Now, everything in the middle is a combination of the other two sides. Not B, but the other two. So it's A squared plus C squared. So it's each side squared added together, minus 2, that's in the formula, that's always a 2, A times C. And that is your law of cosines. That's how it works. So, let's suppose I want to use angle A. What would it look like if I were using angle A? Well, this would be A squared, right? And out here would be cosine A. Now, what would be in the middle?
B squared.
B squared plus C squared minus 2BC. That's it. It's easy. If you sit down and try to memorize it, know the pattern. That's what's important. So A squared cosine A, and then in the middle is the other two sides, B squared plus C squared minus 2BC. All right, so let's try one now and see if we can apply that. So I'm looking on page 42 of my notes. That's where we start, page 42 of our notes. I'm looking at problem B.
That sounds good.
And, oh, this is interesting. What do I have given in this problem?
Side.
Now, your job is to find the angles. You have two choices. Law sines, law cosines. That's it. Those are your two choices. Can you use the law sines?
No.
No, because what's the rule for the law sines?
Need an angle.
You need, yeah, that's right. Gotta have a pair, right? And without any angles, I'm never gonna have a pair. So I'm going to have to use the law of cosines. Okay? Now, you get to pick. I would suggest that when you're picking, start with the smallest angle. Okay? So take a look. Which one of those will be the smallest? C. How do we know C is the smallest? Because it has the smallest side. So whatever angle, or whatever side is the smallest, its angle will be the smallest. So what's the biggest angle in this triangle? Well, not 14. B would be the biggest angle, right? All right, we're going to find angle C. Now, once I've decided I'm going to find angle C, then I know on this side is going to go 10 squared. And on this end is going to go cosine C. I don't even know what C is, but I know cosine of it goes out here. Now, what's going to go in the middle then? 12 squared plus 14 squared minus 2 times 12 times 14. So remember, when you do the law of cosines, whatever angle you're using, you only use one. There's only one angle in this problem. If we're doing angle C, then C, side C is over here. Now this is a little bit harder to type in, so please be patient. Let's go ahead and square everything. So you can use your calculator if you need it. So this is going to be 100. This is going to be 144. Oh shoot, I think this is 196. I better double check. Yep. Now, see these three right here? We're going to multiply them together. So 2 times 12 times 14, 336, cosine C. Remember, this clump has the cosine to it.
Isn't this C 100?
No. This is 100. Side squared is 100. I don't know the angle. If this is a 47, this would be cosine 47, but I don't know what it is. Okay. What do you think I should do next? Maybe add these together? Now, over the years, I grade a lot of papers, and a mistake that's made over and over is kids will add 144 to 196, perfect, but then they'll subtract 336. You can't, because that 336 is hooked to a cosine. That makes it different. Now we can go ahead and add those. So we have 100 equal to,
340.
okay, I'll take your word for it, 340 minus 336 cosine C. Do not subtract these. This is like 336x, and this doesn't have an x, so they can't be subtracted. So if I can't subtract them, what am I going to do?
Subtract 340.
Oh, move the 340 over here. Subtract it over. So negative 240 equals negative 336 cosine.
Yeah.
Now we can divide. So cosine C will equal 240 over 336. Would you agree that the negatives cancel? So now I have this. do I get the angle? Exactly. So now I have to second cosine 240 over 336. Nicely done. Remember, when your variable is an angle, you have to second. So second cosine 240 divided by 336. I got 44.42. Did you?
Yeah.
Wait, where did the negatives cancel? I just got one.
Okay, so this, when I subtracted the 340,
Oh, the negative, yeah. I just
that
did
was
it right
negative
there.
240, and this was negative 336. So I divided by negative 336. So I have no more negatives.
Yeah, I forgot to leave the negative on the thing.
Okay.
So now we gotta do this all over again?
Well,
No, we could do law of sines.
exactly. So now you get to pick. Because could we do it all over again? Absolutely. Pick a different angle and do exactly the same process. But Jaden says, wait a minute. Now I have a pair. So if I don't want to do that again, I can do my law of sines. Okay. So let's jump. I think most of you probably want to do the law of sines. It's easier. I would do the law of sines.
Yeah.
So what's that going to look like, the law of sines?
Sine 44.
Over 10.
All right, so sine 44.42 over 10 equals sine A over 12. Is that good?
Yeah.
So then we cross multiply. So 12 sine 44.42 equals 10 sine A. Now be careful. This is your variable. So what are you going to divide by? 10. So we have 12 sine 44.42 divided by 10 equal to sine A. Now be careful, that's sine A. So in order to find angle A, we're going to have to second sine. Anytime your variable is an angle, you have to use second. So second sine 12 sine 44.42 close parentheses divided by 10 equals 57.13. That was A.
And now you just did bad things.
And now we could do it all over again if we wanted to, but it's easiest just to subtract from 180, add them up and subtract from 180. So 180 minus 57.13 minus 44.42, and I got 78.45. Lindsay? Okay. So we're going to practice some more with the law of cosines. I know it's a little confusing, but tell me again, how did I know I needed the law of cosines on this problem?
No angles.
No pair. That's right. So when you are given, like on our test, it is the question's going to say solve the triangle. It isn't going to say use the law of sines. So you're going to have to look at what you've got and decide if this is going to be a problem for the sines or the cosines. All right, so let's look at the next one, C. Problem C. What do you think in problem C?
Law of sine.
Think this is going to be a law of sines problem?
Nah, you gotta do cosine first. It's side angle side.
It is side angle side. Very good. It is a side angle side triangle. And the problem is I don't have a pair, do I? When we say a pair, we mean angle E and side E? Don't have it. Don't have angle D inside D or angle F inside F. So this has to be a law of cosines. Remember, in the law of cosines, there's only one angle. It's out here at the end. The only angle I know is 104, right? So this is going to be cosine 104 on this end of the problem. That automatically means what's over here all by itself? E squared. Because if I'm putting angle E into the problem, then this has to be side E over here. And then everything in the middle is going to be that combination of 12 and 16, right?
Yeah.
So it'll be 12 squared plus 16 squared
Minus 2.
minus 2
12
times 12 times 16. That's exactly right. When your variable is already by itself, see how that is? The variable's over here. The last problem we did like this, the variable was buried in the problem here. But when it's already by itself, type it in. Just type it in. You don't hit an equals until you get to the very end. So 12 squared plus 16 squared minus 2 times 12 times 16 times cosine 104 equals.
Why are you typing in the calculator this time?
Because the variable you've already solved. It's like saying x equals. This is going to be your answer.
Gotcha.
There's no adding or subtracting to the other side. There's nothing. It's just boom. Right there it is.
You got a really big answer.
You got a real, well, you should have gotten 492.
You
Yeah.
got squared.
Okay, but remember, that's e squared. Right? So if you got 492, you're on the right track. But that isn't e. That is e squared. So now so I don't have to type it all back in, I hit second square root and then second answer. And the answer button, remember, we use it all the time. It's above your negative down at the bottom. And that gives you your answer, which is much nicer, 22.20.
Wait, so you had, after you got there,
I hit my square root button, and then second answer. Now, where do I go? I'm not done.
Now you can do all this.
Now I can do the law of sines. Because now I do have a pair. So what will my law of sines look like? Sine 104 over 22.2 will equal what?
Sine D over 16.
Sine D over 16. So here we go, cross multiply. 22.2 sine D equals 16 sine 104. This is good law of sines practice for our quiz tomorrow. Identify your variable. It's right here, right? This is my variable. So that tells me what I need to divide by. So this time I'll be dividing by 22.2. So sine D equals 16 sine 104 over 22.2. Now, if it said D equals, then I would type it in. But it doesn't. It says sine D equals. So when it says sine D, I know I have to second sign. So here we go. Second sign. 16 sine 104. Close parentheses, divided by 22.2. Did you get 44.37?
Yeah.
Good. Remember, you're filling in those blanks over to the side, so you still have one left to go, angle F, right? What's the easiest way to find angle F?
Subtract.
Add up.
All the angles.
Subtract them from 180, right? So, when I do that, I get 31.63 for F. Does that look okay? So we thought yesterday that law of cosines was going to be really scary, but it isn't. It isn't. We're going to practice it again next time on Friday. We'll practice a little more law of cosines, but right now we're going to finish up the section by talking about area. Area of triangles. What pops into your head when I say find the area of a triangle?
Length times length.
1/2 base times height. Don't make fun.
No, I said it.
Oh, okay. Well, yeah. We're not making fun. But what we need is 1/2 base times height. Now, what's the problem with that? When I look at the triangle that I've been given, I have to find the area of this triangle. Okay, so in other words, what do I not have? A height. I don't have the height. Now, you actually could find a height, but it's not as easy as you think, kids, because this triangle isn't isosceles. So these two pieces add up to 16, but they're not 8. They're not equal. I have no idea what they are. So instead of going to all the trouble of doing that, we're going to have a different formula for the area of a triangle when we have all three sides. Okay, you're going to get 2 new area formulas today, and one of them applies when you know all 3 sides. Because there was a really smart guy back in ancient Greece, I guess. His name was Heron, but the formula now is known as Hero's formula. And it is a very easy formula to use. I'm in awe of somebody so smart to figure this out, but it's a very easy formula to use. We use Hero's formula when we know all 3 sides. Please don't use it in other situations. It works when you have all 3 sides. The formula looks like this. Area equals big square root, and under the square root is this. I'm going to explain what all this means, but that's what's under the square root. That's called Hero's formula. Heron of Alexandria, Hero's formula. I guess he was Egyptian. Okay? Now, you already know what the little a, little b, and little c stand for. In triangle land, what do the little letters, the lowercase letters, stand for? The sides. So this is side A, side B, and side C, which we know. We have 10, 12, and 16, right? As the sides. S is the semi-perimeter. Now we all know what perimeter is. What's perimeter? Distance around, right? When I say semi-perimeter, what do you think that means? Half of it. A semicircle is half a circle. So what is the perimeter of my triangle? Add them all up. The perimeter would be 38. So the perimeter is 38, which means the semi-perimeter is half of that, which is 19. So to find the area of my triangle, I'm going to take my 19, and then I am going to multiply it by 19 minus each side. So the order doesn't matter. So what's 19 minus 16? 3. And then 19 minus 12? 7. And then 19 minus 10? 9. All right, everybody understand where all these numbers came from? S is half the perimeter. Formula says you take S, so there's 4 things down here. There's S, and then there's S minus each side. So now all we do is multiply them together and take the square root of it. So 19 times 3 times 7 times 9, and then take the square root of that number. And the area of this triangle is 59.92. We're going to be doing some word problems. So if these had been in inches, then your area would be square inches, right? In the word problems, we'll need units. And area is square units.
Should we put a unit, like should we put inches if there is none?
Yeah, you don't need to. I just did because I want you to start thinking about these word problems. But yeah, you don't need to. If I haven't put a unit in, you don't need to put it in. Now there's 4 more area problems. Would you look at the rest of them? We just did A. Do any of the rest of these use Hero's formula? D? All right, let's do D then. Let's do D since we just practiced it. And make sure everybody's got Hero's formula down. It is an easy, easy formula to use. All right, so here we go. And we know we're going to use Hero's formula because we know all 3 sides, right? And we need all 3 sides for Hero's formula because we need the semi-perimeter. We need the perimeter. So what's the perimeter of this one?
43.
43. Uh-oh. Don't worry, you got a calculator. What's the semi-perimeter then?
21.5.
21.5. So in your area formula, you're going to start with 21.5. Now, how do we find the numbers that go in the rest of these spots? We take the 21.5 minus each of these in any order. So 21.5 minus 11 is 10.5. 21.5 minus 15 is 6.5. And 21.5 minus 17 is 4.5. Does that look okay to everybody? I use a calculator. You can probably do that in your head, subtract this things, but anyhow, I use the calculator. Everybody okay? All right, so what do we do now?
Square root.
Well, we got to multiply them all together and then square root it. And if you want to square root and then do the multiplication underneath, that's fine. Let's just make sure we all get the same answer. I got 81.26. Okay, so problems A and D are done. and they are Hero's formula. Lindsay,
Since the sides don't have any like inches or feet, we don't have to put a
nope,
label.
you're right, you don't.
Thank you.
All right, so we have one more thing we're going to talk about. Remember I told you you're going to get 2 new area formulas today? And one of them is Hero's formula. And the other one is equally easy. Look at problem B. It is not Hero's formula because I don't know all the sides. The area of this triangle, watch, 1/2, 10 times 12 times sine 58. That's it. I don't have to do any work. I just type it in. Now wait a minute, Mrs. Ford. Where'd those numbers come from? Well, the 1/2 is always there. Okay, 1/2 base times height. That 1/2 is always there. What are the 10 and the 12? Those are the 2 sides. And the 58 is the angle that is between the 2 sides. You see that?
Yeah.
That's the formula. The formula says 1/2 side times sine of included angle. And when we say included angle, we mean the angle that's between the 2 sides. So area is 1/2 of a triangle. Area of a triangle is 1/2 side, sine. So I just type that in on my calculator. 1/2 times 10 times 12 times sine 58. This area is 50.88.
Do you need to put the degree in 58?
It is a degree measure, but I don't need to type
Like,
it in.
okay.
No, because you're set in degree mode, so,
Okay.
no, you don't need it. Okay? Katie?
What does that say, side of?
Included angle. That is the angle that's between the sides. What that means, Katie, is you can't have a situation where you've got the 10 and the 12 and the 58's over here. That won't work. To use this formula, the angle must be between the 2 sides that you're using. Okay? So I'd like you to look at problem C. We just did B. This is the last one we're going to do, guys. Is problem C set up for us to use our new area formula?
Yeah.
It is perfect. This is the easiest question on the test because all you have to do is type in what? 1/2. 16 times 15 times sine 84. When you use this formula, you have to have 2 sides and the angle between. So in the language Jaden was using before, side angle side. So what's the area there? Last one, 0.5 times 16 times 15 times sine 84. What'd you say it was?
119.34.
Yep, 119.34 is the area for that one. All right, so we got a lot going on.
Now we do.
We've got our 5-5 homework is due tomorrow, is that right?
Yeah.
Friday.
The homework.
I think it's
We don't have
Homework's due tomorrow. But you turn it in, and we email it to me, bring it by or whatever. And then we have another quiz on Friday. And what is that quiz over?
5.5.
Well, which is the law of sines. what does the quiz look like? I gave it to you, right? So you've got that. Well, yeah, and then we'll work some more on our notes. Okay. All right. So, girls, you all can square on everything? All right. See you later. Bye. Also, guys, how important is it for you to have your calculator on Friday? Important. Yeah. You gotta have your calculators, kids, in order to do the law signs. The quiz today, you did not need it, but you need it for the law signs. So, if you're not too exhausted from basketball, we can Move it. Right. That wasn't the response I was expecting.
Before you should just automatically assume high schoolers are not. High school.
Yeah, I know. Those dudes were like, they didn't want me to press a lot.
I said just as all the high
No,
school.
they were beating us.
I thought you said they aren't.
Bro, those dudes, or they didn't have enough. They like had their team together that they thought was like the dream team, and like none of them wanted to show up. I was like, well, look, you get 9 playing a little sibling.
Oops, I need to turn the video off. We're done with that.